welcome to Smart Architectural Programming. My name is Mohammed, and coding alongside me.
is George, and this particular video will be the first of another series of videos that we'll be doing that will continue to delve a little bit deeper into data structures. We have another video which we'll link in the description section. But Mohammed, I'll let you take it away.
So as George said, this video is going to be the start of a series of videos that are going to go over Python data structures. And these are very important topics basically because most most interviews, programming interviews, usually test content related to Python data structures and algorithms. So understanding individual data structures that are available to us as a programmer is going to be a very essential skill that you need to command if you're a professional programmer or you intend to become a professional programmer further down the line. So the first video is going to be about a data structure called stacks. And while a lot of other people use visualizations and other things to explain these concepts, for us, we'll be focusing on using Python code, practical code, to depict how these data structures are within actual code, so that because that helps you understand exactly what you're looking for and what you need to develop as a programmer in Python. So what are stacks? So stacks in simple terms is a fundamental data structure that follows the last in, first out principle. So what does that mean? So basically imagine you have a pile of books, right? From top to bottom. You have a tower of books rather, right? And you play once you're done studying with a book that you were just reading right now, you place it right at the top of that pile of books, right? Or tower of books. Now, that's the last book that you read placed right at the top of that book pile. Now, imagine if you want to if you want to take out a book again from that tower, but you can't go sideways, you can't go down. The only way you can get that book out is from the top. Now, what would you do? Pick the first book that you placed last time back up again. So that was the last book to go, but the first book to be taken out. Now, in programmatic terms, if you want to understand what this means is, if you have 10 functions that need to run, right? And the what how we can explain that in the terms of stack by being that if you initiate, let's say, a summation operation, a subtraction operation, and a multiplication operation in that order. So the last operation in that stack was the multiplication operation. Now the computer would first execute the process, the multiplication operation right at the top, then go for the subtraction operation, and then go for the summation operation in that order. Uh, in that order, which meant the last operation placed was the first one executed. So in simple terms, that is what stack means in computer science. Now, let's go deeper into the stack and understand it, how it looks in Python code. Now, right at the start, we have defined a Python object called stack. Basically, this is how a stack would look like if you define it in Python. So first we define a list. Again, data structures are all about visualizations. So list could be a stack, it could be something else, but in this case, it's going to be a stack because we're creating a visualization, and the structure below would further propagate that idea of this list being used as a stack. So first define a list, right? Then, for error handling purposes, and from line 5 to 7, we define a method that clarifies that clarifies. So, as I was saying earlier, the first method that we defined for the stack object was the is empty method. from line 5 to 7. Now, what this method is, it's mostly a method to check if the stack is empty. As you'd see before in the other methods, make sure that we do some error handling, certain errors, pushing, popping, or peeking in stack. The next method we define from line 9 to 11 is simply one of the core aspects to our stack would be the push method. What push method is, it places an object on at the end of the list every time we use that. And to do that, we use the append method within Python's library, and append whatever item there is onto the end of the list, which is going to be a stack. Now, the pop, it's gonna next we define the pop method from line 13 to 18. Now, what this does is it just pops up the item at the end of the list, that is at the rightmost end of the list, and removes it. And this is a perfect visualization or perfect execution of a stack. By push, we place the object right at the end of the list, and by pop, we remove that object right at the end of the list. So both operations are done at the end of the list. Place an object, that's last in. We remove the object, that's first out. So those are some two basic operations of a stack that we conduct using the push and pop methods that we define. Keep in mind we did some error handling here, which is to just see if our stack is empty or not, because if you're pushing or popping without that, it's going to raise errors if the stack is empty. So if in pop we check if an object is there or not. If it's not there, we return none. If there is, then we do the pop method. But again, you cannot pop off an empty. Now the peek method is again method in, like unlike the pop and push methods that we defined above, in which we are either placing an object at the top of the stack or removing an object from the top of the stack. The peek method does not place or remove anything. The only thing it does is looks at the top and sees what element there is or what book was placed at the top of the tower. It tells you what that book was or what that element was. That's it. That's all it does. And again, to error handle, we make sure the list is not empty because you can't see what's not there, right? And that is going to raise an error. So we just do an error handling to check if the list is empty or not. If it's empty, we return none. If it's not empty, we go to the last digit on the items list and just return that. Uh, items near items, you'll see a square bracket with -1 in it. So basically what this does is, so if you our list from usually starts from left to right, and the indices or the indexes or the placement of the list from left to right starts from 0 1 2 3 4 5, right? But if you want to start from right to left and you want to find the first object on the right, you start from -1. 0 is the first object from left to right, so we can't use that. But 1 is the object, the second object from left to right. And we flip that and use -1 from right to left. Minus switches the direction that we're using. Usually it's from left to right. Minus changes it from right to left. So that's basically the simple, logic behind using that here. So we just look at the element there and just return that. The last method is size, in which we basically which returns the number of items that are within the stack. The first, like again, this is more so of an error handling, uh, method. It's not that pertinent to the understanding of the stack in question. So now we move on to line 31 onwards is our execution execution part of our code. Here we execute the code. So on line 33, we instantiate the stack object. In line 35, we print, we use the isEmpty method, which should obviously return true because we just instantiated a stack object, and prints on the console the stack is the stack empty with a response of true, because that is what the method returns to us. Now, then we push from line 37 to 39. We push numbers 1, 2, 3 using the push method into the stack. And on line 41, we using the size method that we defined right at the end of the object, we identify the size of the stack and print it to the console, which is 3. And on line 42, we use the peek method to see what's at the top of the stack, what number is right at the top of the stack, and we print that to the console as well. Then on line 44, we create a variable called popped item, and we use the pop method of the stack to remove the item right at the top. That would be the number 3 in this case. And then we print the popped item, the item that we just removed from the stack. And we also then check the stack size again, which should return 2 after the removal of one item. Now, at the end, we're just going to run this code, and we'll see we're getting the same answer. Is the stack empty? True. Stack size 3, top element 3, popped item 3, stack size after pop 2. And that is basically pretty much all there is to what what stacks are. Again, if you have any data structures that you would like us to focus on, please let us know in the comments. If there are any topic that you're confused about, again, let us know in the comments. Or anything that you didn't understand in this video that we could explain better, again, let us know in the comments. And with that, this video comes to a close, and we'll see you on our next video.